In this session, we'll provide an overview of the Kalido Approach, which is an agile, iterative methodology designed to ensure you get the most out of your Kalido deployment. Kalido markets the Kalido Information Engine for data warehousing and master data management applications. Customers use Kalido Master Data Management for MDM projects, either to feed good master data to operational applications and/or in concert with Kalido Dynamic Information Warehouse for data warehousing and business intelligence applications. While Kalido DIW is frequently used as a foundation for analytics as a typical data warehouse, many customers also think of it as a place to integrate data from many sources and use that data wherever they need it, when they need it. Some examples include feeding an ODS, feeding other engines such as financial and planning applications, or even preparing integrated and consistent data for deploying new operational systems. In any of these cases, deploying such a solution can be a daunting task. It's a complex exercise with broad scope and reach. In this session, we will introduce why you need a new methodology that is different from what you may be familiar with for building traditional warehouses and other operational systems. We'll discuss why the traditional waterfall approach and its gated delivery method is not an appropriate approach. This will lead into a discussion on the optimal way to structure a project when Kalido's broad range of automation is available. Let's start with looking at the traditional data warehouse approach. If you look at statistics from TDWI or any of the major analyst firms, a common thread is the high percentage of data warehouse projects that run long or don't quite solve the problem that they set out to accomplish. Most data warehouses also have a fairly short lifespan, which doesn't match the purpose of these systems. One of the key reasons that these problems occur is that in the process of creating your warehouse, for whatever use you intend, you will encounter data quality issues and will be faced with data integration challenges. Historically, people have attempted to address these through ETL tool programming, which is manual labor intensive, and the traditional waterfall approach tends to deliver a hard-coded structure for the DW. This hard-coded structure becomes brittle and difficult to change over time. This makes the warehouse obsolete and is a major reason why these DWs have such a short productive lifespan before the organization seeks other ways to deliver data for analytics or integrated data for use in other systems. Let's first look at how data warehouse projects are different from operational systems. Most organizations initially implement operational systems to support specific business processes. They then reach a point at which they need to produce analytics across those operational systems and start to include data that originates external to their organizations. This drives the need for a solution such as a warehouse. By this point, however, these companies are very competent in implementing and operating these operational systems. This new warehouse with integrated data is seen as just another system, so the same implementation and operational processes are applied. However, an integrated warehouse environment is fundamentally different. It isn't limited to a single business function, so it goes across business processes. This implies that its audience is a lot wider and is initially less trusting of data they do not deal with on a day-to-day basis. These users are also less sure what they want out of the system, as the scope goes beyond the traditional business processes that they are comfortable with. The biggest difference is that these integration environments are much more prone to change. You need to change your business process before making a change to an operational system. This is a slow process that happens infrequently. However, the focus of the integration environment can change in a very short period of time due to an internal event like a reorg or an M&A, or an external event like a competitor moving into a market that they previously did not focus on, but which drives a significant portion of your revenue. Finally, a new business strategy or regulation could change the analytic environment without initially changing any of the operational processes. Then we look at how these warehouses are implemented, and this is the traditional approach that has been recommended and followed for decades. It's typically called the waterfall or gated delivery process. You start by capturing requirements. This is usually a book produced by an analyst rather than anyone who will actually be designing or building the system. It assumes that the users know exactly what they want, so it captures everything down to report formats and formulas. How many times have the report formats stayed the same? How many times has the user changed their mind on the formula once they eventually saw the output? So at the end of the day, we know these requirements are incomplete. That book of requirements is then handed to another team that starts to design the system. This sometimes starts with a conceptual model which the user community still understands and can relate to. However, once we move to the logical model, the language used by the design team is so far removed from the end users that they're no longer involved in the process. So we take incomplete requirements and interpret the contents to produce a logical model. That is then handed over to another team to produce a physical model. However, there isn't just one physical model. If we're following industry best practice, we have a physical model for the staging area, a physical model for the integration layer, and a physical model for the reporting layer. So now we have at least 3 representations of the requirements. The initial book, which we agree is incomplete, the interpretation of the book, which becomes the logical model, and the interpretation of the logical model, which becomes one or more physical models. Then we get to the biggest problem with using this approach for data integration problems, which is test. When building an operational system, the data does not exist as the operational system creates the data. However, for an integration environment, the data mostly exists at the point of requirements. But test is the first time that we truly start to flow data through the system. So this is the first time that we really start to see the effects of quality problems. This is the first time that we see where integration rules don't quite work. But once we're in test, we can't go back to design. All we can do is go back to develop and build a workaround for these issues, instead of designing for quality and integration, the 2 key reasons we're building this environment in the first place. And finally, we release to production and move into operate, because once the system goes live, we've solved all the requirements accurately the first time around. This approach is just not appropriate for effectively solving the data integration problems you will encounter when building and deploying the data warehouse. So are there alternatives? The most common set of alternatives all result from the Agile Manifesto. Scrum is probably the most common. However, there's also extreme programming, Microsoft's Spiral, Toyota's continuous improvement process, and the list goes on. However, I want to go back to the numerous variants that have resulted from the Agile Manifesto. Why are there so many, and why do people so fervently defend theirs and attack others? At the root of these variants is that people have taken the Agile Manifesto and developed a methodology that works with the particular combination of organization and technology used. This is the reason that the methodology has been successful in their particular use case. The methodology should always cater for the technology being used. We do that in every other facet of our lives, but in the IT world we tend to follow the philosophy of having methodologies that are technology agnostic. What this results in is using technology rather than exploiting technology. So, if we want to exploit the Kalido technology, how should we run a project? What you're looking at is a high-level representation of the methodology that Kalido has produced based on the Agile Manifesto. At first glance, it doesn't look that different from the traditional gated delivery. However, as I go into the detail of each of the phases, you will see that they are drastically different. The first thing to notice is that the outer box says program management rather than project management. You have to look at these environments as ongoing programs. Unless you plan on freezing your business environment, there are always going to be new information requests and new ways that people will want to look at existing data. This means that maintenance is no different than your initial build. The program drives the prioritization of business requests, and a project is instantiated for a particular set of business requests. There are 2 key points here. First, each project is always focused on solving a set of business problems, not technical problems. Second, the project needs to be driven by time rather than scope. When planning projects, there are 3 variables that drive the project: resources, scope, and time. You can only control 2 of these at a time. The traditional approach states that you fix scope and time and you manage your resources. But we all know that this doesn't work when it comes to integrating data. So how about we fix time and resources and manage the scope? This might sound like heresy. However, we know that we are not going to get complete requirements. We also know that these environments are much more prone to change, so we should build a process that accommodates change. Fixing the time and resourcing also means that you can be a lot more predictable on both budget and delivery time. From a time perspective, you need to choose a time period that is short but reasonable for your organization. We use 3 months as the average. The reason for this is that it forces you to deliver concise pieces of functionality. This way, the business users get smaller pieces of functionality on a more frequent basis, which means that they not only get more timely results, but that they spend more time doing quality verification, since they have to verify less at a single point in time. These concise deliverables, however, don't mean that you have to work through your list of priorities in a serial manner. You can run concurrent projects for large programs. The key is that you can still think big, but you start small, iterate through the problem, and evolve your data warehouse into an enterprise-wide integration environment. Since we're talking about project and program management, let's do a slight detour and look at the project team. This approach mandates a small, experienced team. Optimally, this team is co-located, not just in a building, but in a room. You could still use this approach with a distributed team, but you probably won't be able to achieve 3-month deliverables. The main reason for this is that when you're driving such short deliverables, communication latency has a much bigger impact. Waiting for a day for someone to respond isn't a huge problem in a 9 or 12-month project, but on a 3-month project, you've burned through just over 1% of your implementation time waiting for a response. The second key feature of this team is that it is cross-functional. By that, I don't mean that just the various IT functions are part of a single team. Cross-functional includes the key business users as well. There's a single team whose mandate is to solve a particular set of business problems. I'll go into more detail about the benefits of this as we progress. One of the frequent questions that we get is, does having all those people co-located in a single room actually reduce productivity? Actually, it's quite the opposite. Yes, the room can be noisy. However, there are usually conversations that draw in others with insight who have not initially been considered to be part of the discussion. All of this drives towards reducing the latency of communication and forcing communication to be direct. This is crucial when slight disagreements on terms or definitions can have huge impacts on outcomes. Each of these project teams has a project manager who is responsible for ensuring the team sticks to the end goal of solving the business problem. The team business lead should be very knowledgeable in the problem being tackled and should have easy access to a wider array of resources for questions that she cannot answer. On the technical side, there's a single architect for the overall solution. This person goes across all technologies being used to solve the business problem. Having an architect for each portion of the solution leads to local optimization. There is, however, a resource responsible for the design in each of the data phases. At a high level, this is typically data acquisition from sources, then the integration and management of data, and finally, the delivery of information to the end consumer. Each of those designs fits into the single architecture driven by the solution architect. Finally, no one disagrees with the request that there needs to be business involvement in projects like these. However, when it comes down to the implementation, it is typically business analysts who are provided, rather than people that make day-to-day decisions on the data and are the direct benefactors of the problem being solved. Business analysts are hugely valuable in coming up with definitions and fleshing out complex calculations. But only someone who actually makes decisions on the data can guide the appropriate pathway to quality and integration issues. Remember that the reason we are building these environments is to have consistent quality and integration. Most integration boils down to a set of business rules which cannot be derived purely from the data. A common response to this request is, "Those people are too busy, we can't trouble them." I guarantee that if you are going to make their lives easier, they will give you the time and knowledge you need. The corollary to this is that if you can't find a business person that is willing to give this time, then you should probably relook at the scope you're planning on tackling. So moving back to the approach, we have a phase called define rather than requirements. This is where we capture high-level, business-oriented requirements. We know that the requirements are going to evolve as users get to interact with data. Formulas are going to change, assumptions on rules are going to change. So there's no need for detail requirements at this point, since we know that those are going to change. We should have a set of business questions that need to be answered by the end of the project. We should also define where we should source information to answer those questions. But we don't need to know the report formats at this point in time. If the detailed requirements are going to change, the reports are probably going to change as well. We don't need a detailed list of all data elements available in each source, as we're going to drive this from a what is needed perspective rather than a what is there. We also don't need the detail for formulas and calculations, as these usually change when users see actual data. This means that we can spend just a week or two gathering these high-level requirements. Now we get to the heart of the approach, which is the iterative design. This is essentially a combination of detail requirements and design using real production data. The reason for this is that as users see output from the design, they crystallize the requirements, which feed back into the design process. Each iteration tackles the whole model, and you should typically have at least 3 iterations. The key to tackling the entire scope is that you want to front-load all the data issues that typically only come up during test. This is the only way to ensure that you design for quality as well as integration. The duration of an iteration is variable. The typical range is between 1 and 5 weeks. It's determined by a variety of factors, from understanding of the business problem to understanding of source data. If all your sources are in-house and you have ready access to source system expertise, then you will probably have shorter iterations. However, if you have a few external sources that you have no experience with, then you probably need at least the first iteration to be on the longer side. The same pragmatism needs to be applied when it comes to the number of iterations. If you have a defined problem that is only for a single functional group, 3 iterations might be sufficient. But if you're solving a totally new problem that goes across multiple functional groups, you will probably need more iterations to drive consensus of definitions and rules. The key to this is the Kalido technology, because it supports this process by allowing you to rapidly produce prototypes and keep business involvement. Let's look at this iterative process in more detail. Remember that we're tackling the entire scope in each iteration. The expectation, however, is that you won't be at the most granular level of the model during iteration 1. By tackling the entire scope of the project, you are verifying the core entities in the model and their associations. Each iteration, then, will take you down to a lower level of detail. The reason for this is that there is no need to figure out all the attributes of product if we can't figure out how to consistently associate a product with a brand. Our high-level requirements are fed into the first iteration. We collaborate with the key business users to come up with a business information model that represents an initial understanding of the business landscape. The key point here is that this becomes a top-down driven process. Thinking back to the define phase, this is why we don't need a list of detailed attributes. We're going to drive the attributes required from the business perspective, rather than from what is available in the source. This has 2 key benefits. First, you only bring the required data into the integration environment. It's the data that isn't required that typically gets little or no validation and hence tends to cause operational and load failures in these systems. Second, this is the way to find the various spreadsheets, access databases that exist in the environment and start to bring them into the integration environment so that they can be managed like any other piece of valuable shared data. Finally, this process is going to drive the consensus on shared data, master data, or common reference data. Due to the automation capabilities in Kalido, you can now immediately move to populate the model with an appropriate sample of production data. It has to be production data because this is the only way to uncover quality and data exception problems. The appropriate set means that the data needs to make business sense. The numbers matter, so when a business person looks at an aggregate coming out of the system, it needs to make business sense to them. This subsetting can be done by geography, business unit, time, or a combination of those. You want a set of data that can effectively validate the design, but not so large that you spend most of the time allocated to iterative design waiting for data loads. This data does not have to originate from a productionized extract. Use the quickest method available to source the data because you don't want to spend time productionizing extracts until you have verified what should be extracted. Once we've loaded data, we can engage the business again and show them output. This output is typically in something like Excel, so the user has easy ability to slice and dice the data to begin to understand it. We're looking for validation of data content here rather than the end visualization of the data. What this does is bring the business user into the heart of the design. However, they interact with the design through the data. Two key things come out through this process. One, we find poor quality data that might be systemic. We have the flexibility to now build an ongoing process to cater for that data. Two, we find valid business cases that we didn't think of in the previous modeling session. This results in a model change, and we start the cycle again. During this session, there should be a single list of business and technical issues that are jointly managed by both the business and technical roles. Having the business users this involved in the process is the only way to take the approach of actively managing scope. Finding out that there is lots of low-quality data, so we are going to remove one of the business questions from the current project to cater for an additional quality process is a joint decision and is transparent across the team. Once these decisions have been made, we go through the full cycle again. Each iteration takes us closer to a design that fits the real requirements. Let's talk a bit about actively managing scope. In the traditional build world, this is called scope creep and is one of the words that shall not be mentioned. However, if we look at one of the root causes of scope creep, it is due to the business obtaining a deeper understanding of the problem, or their thinking on how to solve the problem has evolved. At the end of the day, both issues are good things. If we incorporate them, we provide a better product. The other reason for scope creep is a business change that has happened, such as a reorg or an M&A. The best way to mitigate this risk is short deliverables. The possibility that there are multiple external events like an M&A or a reorg that will affect a 3-month project is small. However, the probability that there are multiple external events in a 9 or 12-month project is close to 100%. Catering for a single major event is usually not a problem in a well-designed system. So at the end of the day, scope creep is really a good thing. It means that we are producing a system that more closely fits the business needs. This is why it is crucial to have a process that allows the scope to evolve. The key word here is evolve. This doesn't provide the license to totally tackle a new set of problems halfway through the project. Short projects mean that the priority of the deliverable should not change substantially during the duration of the project. We are going to cater for small adjustments to the scope, but a fundamental change to the scope results in a new project. The key to being able to achieve this process is that you have to have just a single representation of requirements. You also need significant automation so that you can continually focus on the business problem rather than devolve into a purely technical effort due to technical complexities. There should also be a common theme of document generation rather than document creation. Hand-created documents are usually out of date as soon as the implementation starts. Moving towards document generation directly out of the system not only means that your documentation is always up to date, but it also means that in the time it would have taken you to write a requirements document, you have actually prototyped the requirements and validated it. You then just generate the document that represents the requirement. Iterative design means that we have fully validated the design of the system. So when we get to build or productionizing the system, the development team is a lot more confident in how to source data and the dependencies between operations. The build cycle is relatively short, since the artifacts that come out of design are all usable in a production system. They just need to be wrapped in process automation to run in a production environment. This is also where the final reports are designed and built. This can be a significant variable to the time allocated to build when the number of reports is large. You can have 100 simple reports, but creating the layout for 100 reports is still going to take a reasonable amount of time. We have a similar scenario when we get to test. Packaged software means that there is minimal unit testing. However, more importantly, test is not the first time that business users are interacting with data coming out of the system. They've seen the data numerous times in the past during the iteration reviews. All we are testing is that the data is now produced in the appropriate interfaces, be they reports or a feed to a downstream system. We're also looking at an end-to-end system test. The big change to testing is that we should not experience any major data issues if we followed the iterative design process. Post-deployment of the project means that there is a new deliverable available to users under the program umbrella. A new project will tackle the next set of high-level requirements. The best approach to handling the data integration problems when designing and building the warehouse is to be pragmatic. The easiest way to achieve pragmatism is to have real business involvement through the entire development cycle. Without full business involvement, these projects quickly become technical exercises. The team tries to find a home for every attribute that exists across the sources. They guess at quality, and the only acceptable response is 100%. These are all things that change drastically when there's full business involvement, because the usage of the data is taken into account. It could be used for closing the books, and you need to reconcile to the penny. However, you could also have the case where you have a few exceptions that do not reconcile, and a business person decides that due to the use of the data, those missing exceptions will not affect the decisions that they make. So we move the system into production with the known limitations, and a future project that requires 100% of the data to reconcile will take on the task of dealing with the exceptions. The users will also drive how some of the architecture is implemented. It might be technically cool to trickle feed your environment, but if the users want consistent reports across a business day, then implementing a batch approach is probably the better and simpler technical solution. Another area for pragmatism is in business rules. Kalido may not be able to handle every business rule you need using its standard built-in functions. There may be times when you need to write SQL or use an ETL tool function. However, don't let a small percentage of rules that you may need to create outside Kalido's automated capabilities drive the architecture decision for all business rule creation. Use the best solution available across all the technology that is available. This is the reason that having a single solution architect is so important. Being pragmatic means that you can get a business-usable solution to production in a shorter period of time. A valuable exercise to perform at the end of each project is to have a post-implementation review. Just like we're not going to get the business model exactly right the first time round, we're not going to get the development process right the first time round. It's valuable to assess what portions of the process worked well and which portions need improvement so that the process can evolve over time to become more efficient. This is also a good time to document the true cost of the project as well as the perceived benefit from the user community. Following the Kalido approach in building your warehouse environment and thereby solving the heterogeneous data integration problem allows small teams to incrementally tackle business problems and produce actionable results in a short period of time. This more tactical approach, however, does not detract from the larger end goal of having a fully integrated and consistent warehouse environment. The smaller scope definitions allow rapid iterations through the problem, ensuring that data quality and integration are fully designed for ensuring a quicker build cycle and fewer defects that occur during test. Kalido Professional Services has extensive experience in helping customers fit this approach into their organizations, as well as assisting customers in planning for their projects. Please do not hesitate to contact them for assistance.